Here's the last part of Chapter 11, briefly talking about things that we know less about. And we'll talk about antimatter and dark matter. Um, the matter that we have studied and are most familiar with is when we talk about atoms with nuclei and negative electrons. And that is what we've studied, that is what we're familiar with. What the speculation is now is that matter is contrasted with antimatter, which is the opposite, where the nuclei are negative and the electrons are positive. We call them positrons rather than um, electrons. And part of the reason why this change in thinking has happened is that for a long time the idea had been that the proton and the neutron were the fundamental particles, but the current thinking is that they in fact are composed of quarks. Um, and this is an evolution of science, the same way that when we studied Newton and Copernicus, that they challenged what people before them had thought. This is what's going on today, and is a refinement to the models and replacing understanding. Um, to our knowledge, matter and antimatter cannot coexist, but the speculation is that in the universe there is a significant amount of antimatter. And a little bit more detail about positrons and the antiprotons, which is what the composition of antimatter. Dark matter is even a bigger mystery in today's physics, and you know, probably when we understand it more, will make the periodic table obsolete. Because the speculation is that the bulk of the universe is not stuff on the periodic table, but it's something entirely different that we can't quantify. Um, dark matter is speculated to be part of the matter that we know, uh, including perhaps you and I and the Earth that we understand. Um, as an example, the idea was that the core of the Earth was predominantly iron, or all iron, and the current speculation is that it also includes dark matter. Um, and again, dark matter is one of those things we know it exists because of the reaction of things around it, and a very high-focused study of advanced physics now. Just as a quick review and an expectation of what we've got coming forward, we've kind of looked on the inside of atoms. For the rest of the chapters in this short unit, we are going to look outward and consider solids, liquids, gases, and plasma, and the different states of matter or phases of matter. So the different things that these electrons and these atoms and molecules will do, how we measure them, how we quantify them, and how Newton's laws apply to them.